Welcome back, students. We are now in the last section of our discussion, the topic 2 about the irrational numbers. I would like to ask you, as I've always been doing in the previous videos, the link down here. Let's be together and finalize it. Right, today in the video, we're not going to do much. I just need to see where we can apply the knowledge of what we have just discussed in the irrational numbers. So here I'm taking you into another area of concern. That's to say, you as students, you should also expect that most of the times questions in maths, they don't usually come direct. You may be able to see that some questions can come direct as we've been doing in the examples, but somewhere, some examples can come in the applied form. That's a way questions may come in the form of words, where they always ask you to express the solutions of which in simplified sad forms. So that area I needed at least to discuss with you. So when the questions comes and demands you to do that, how do you go about it? Hi. So here I've got two problems of which we're going to solve together, and let's be together until we end up with, so that each time you have such type of scenarios, try to do the same as we're going to discuss here. Right. Question number 1. We have a triangle which is ABCD. Sorry, triangle ABC, whose dimensions are as follows. AB is 5 centimeters, BC is 10 centimeters, and the angle of which, one of the angle there is 90 degrees, defined as BAC. What we're asked to do there is just a matter of finding the value of the length AC. But your answer should be expressed in simplified sad form, or leave your answer in sad form. Right. So here, what they're trying to emphasize is that the answer should be in sad form. It means that at one moment in time, you may have a situation whereby you need to express that answer in another form. It could be a decimal fraction, but in this case, they don't want you to leave it in that manner, but you have to see the answer in sad form. So if that's the way question comes, what does that mean, and how do we express solution to that type of what? State. Right. So first to understand that, let's just solve the entire question and be able to discuss that angle. Right. So we have a word problem like this. So as I've been telling my students in one of the school, that always, whenever you're handling problems which are in the weight, you need at least, where necessary, if it's necessary, to at least present the entire information of the question in the form of the diagram. Right, because by the diagram, you may be able to see everything clearly about the shape that is highlighted in the question. And that one is going to give you a guide on how best you can handle that problem. Right, so now, like in this case, we are given a triangle ABC. So it means here you're going to draw the sketch of which that is triangle ABC. But you have got several types of triangles. Some are scaling, some are isosceles, some are right angled. So by that, you may also be able to have your sketch designed to that, depending on the question you have. So when you draw the sketch here, try at least to relate to the types of triangles that were given. That's the sketch, but still more, try at least to be realistic. Like in this case, we are told that one of the angles in this triangle is 90 degrees. Then obviously you can depict that, say this triangle is right angled. So when you're coming up with the sketch of which, try to make sure that the triangle you have is right angled by just inducing in the what? 90 degrees as one of the triangles. So here my sketch will be like this. Have a shape here. I got like this. Look at that. Like that. So whatever it's there, this angle, I'll present it as a right angle by that side. So I'll write that with 90 degrees. So this is the one that is defined as BAC. So here it means wherever for the other bit says here I can have a B, it means my A will be here because it's the middle that will refer to the particular angle. So my C will be here. Right. So if you look here, the triangle is still defined as ABC. So you can begin to say ABC, where our BAC is 90 degrees. What is side AB? This one here is AB, is given as 5 centimeters. And this other side, BC, is 10 centimeters. BC is 10 centimeters. So here, what we are asked to do is simply to find the value of what? AC. In this case, our AC is this one here. Right. Now, it's just like now, how are we going to find the value of AC? How are we going to find the value of AC? Right. As a mathematician, always try how to detect what procedures can we take in order to solve the question. Right, more especially in the word. So the information in the word may be able to guide into the appropriate what? Information that can be used to handle that question. Like for example, this question is talking about finding the length of a side of a particular shape. In this case, it is a what? A triangle. So all the students should be able at least to figure out, to say out of the areas that I've read, even studying with the JCE, which areas, okay, were we discussing about the what? The length of a side of a particular shape, be it a triangle or rectangle. You find that when you are mostly working out the side of a triangle, most of the times, if the triangle is right angled, you'll be able to see that the problems of which were handled better by the use of what? Pythagoras theorem. Right. So in this case, I don't think if you can learn away from that concept, you are just there directly and you can see the triangle is already right angled. Then possibly here to find the remaining side of the triangle, which is AC, you have to go toward that side. Right. So certainly in this case, let's say I can't even go for what quadratic expressions. What will quadratic expression help me to solve for the length here? We didn't talk of that. You can't go for the what? You talk of issues about, talk of maybe you did about the like inequalities in Form 2. You can't think of that one. But area where you discuss about the finding length, you find that you are talking about the shapes, talk of Pythagoras theorem, so we are going there straight. Right. Now, I'll take for granted that you students also know the statements about the Pythagoras. So we're going to introduce that one here. So this question, to find the value of AC, we're going to use Pythagoras theorem. Right. So here we go that say by Pythagoras theorem. We've chosen this theorem because of the nature of the question demands that it is talking about the length, and it's only by that we can find the value of what? The size of a particular shape. Right. Now, here we are. You have a triangle here. So if you like to use a theorem about Pythagoras to find the value of a particular side that is remaining on the triangle, in the triangle there, remember first to write down the statement of that Pythagoras. Okay? So from there, once you have derived that statement of the Pythagoras, which is just like a relation that talks about the three sides of the triangle, then you just go the substitution. After done the substitution, what do you have at the end? You're going to have the value of the side which is missing, in this case AC. Right. So like here, just to remind you a bit about the Pythagoras theorem, it is that statement that always say that, say, if you compare the three sides of the triangle, one side is the longest, and that side is known as the hypotenuse. That side being the hypotenuse, you can know it by what? It's the side that is always facing the right angle. Like in this case, side BC is opposite to 90 degrees. This will always be the longest side. So what does the statement by Pythagoras state about the three sides of the triangle, including the longest? Well, these are the two shorter sides. This tells us to say that the square, that's the square in BC here, longest side, on the hypotenuse side AC, that one is the same as the sum, that's the addition of the squares of the other two sides. So here we're going to square AB and then we add with what? AC, like that. So that's what the statement of Pythagoras states. So you talk of BC squared is equal to A squared plus AC squared. BC squared plus AB squared plus what? AC squared. That's it. So this is the relation that there exists between the three, among the three sides of what? A triangle, which is only right angled. So once this one has been taken, has been written down like that, what do you do next? Then just have to substitute where values are given. Where values are not given, it means that is the part that you need to wake up on. So like here, BC is given as 10. So it means instead of writing BC here, we're going to write 10, which has to be squared. And here we'll have AB. What do you have for AB? AB is this side here, which is 5. So it means here I'm going to write a 5, and I'm going to square it out like that. But now when we consider the AC here, we are not given anything. So possibly that is the side that we are to find here. See, you can see the question, they say find the value of the length of AC. This is the missing side. So what do we do then? When it comes to substitution, there's nothing we can do, but we just have to rewrite like that one as it is, AC squared. So it means in this equation that we have here, we have got a number here, we have got a number here for that terms, but here it's missing, so you can more just like you are trying to solve the equation of which. Right, so let's proceed on that. So we have here 10 squared is as good as giving us what? 100, right? And then for the 5 squared, that gives us what? 25. Then plus for the AC squared, there's nothing we're going to do that one. We just write it AC squared like that. Right. Then next, what do we do? Right. Rules of the equation say that like terms and be lines together. So what do you have? Your 100 in this case comes in like this. And then this one has to be paired up with what? The 25. So you transfer this 25 to the left hand side. And where now it is positive, there now it will be negative 25. And that one will give you AC what? Squared. So it means 100 squared, sorry, that's the 100 is subtracting what? 25. Right. So when like this one is equal to that one, is as good as writing AC squared is equal to 100 minus 25. It's not a problem there. This side is that, that is that. Fine. So here we go, AC squared, 100 minus 25, the answer will get easy, 75. Right. So when you reach that stage, you may be interested to find of AC, but AC squared is 75. But what you want is AC. So what do you do here? It means you have to eliminate the power, which is a 2 there, and just isolate the AC, or AC should be alone. So in attempt to get rid of this 2 here, what you do is, you do just have to take the square root on both sides. Right. So when we're taking the square root on both sides here, we'll have our AC here. The square root of AC squared is AC, and the square root of this one, it'd be like that, first of all, square root over 75. Right. So it means the side AC is the square root of what? 75. Right. So now, at that stage, is where now you need to at least consider the nature of the solution. Right. So here, don't proceed. This is the time now when you can follow this one, instruction here in the question. They say leave your answer. My answer is this one here. They say inside form. Inside form, it does not mean that you need then there to continue on that. Because if you are going to proceed here, in working out the square root of 75, you are going to get a decimal number. So it means here we don't want any other number which is in decimal, but it should just be in a root, or say in irrational form as such. So what you do here, it means as much as you have got root of 75, this is already a surd. You can't have the square root of what? 75. So you leave it like that. Don't proceed by using a calculator, having the square root of 75 in decimal number. Right. But the only thing that we can do here is by what we did in the first video. Follow using the link down here, where we're discussing about the simplification of surds. So what you do here, you just need to simplify the 75. So from what we discussed there, in simplifying the surd, we said that you just need to express the number inside the root into 2 factors. One should be a rational number, or say irrational factor, but the other one could be a perfect number. So what I'll do here is simply just look at 75. 75 is coming from a perfect number, which is 25, multiplied by a 3. Right. So if we are going to go look at the 2 factors of the 75, which is 25 and the 3, you'll be able to see that 25 is a perfect number, while a 3 is not a perfect number. So if we're going to split the root, this will be a rational number which will have its square root, but the 3 will be the irrational factor. So it means that case we have split the 5 into 2 factors. One is the perfect factor, the other one is irrational factor. So finally, what do we do there? What we have is this. So I'll take you here. We go up, up, up. We're going to end here. Right. So the solution of which it means the value of AC shall be equal to Okay, let me just lab this diagram. I think you already have it. Right, so for the logical purposes, right, so it means here the value of AC shall be equal to square root of 25, it give us a 5, but square root of 3, we don't have it, so we leave it just like root of 3 as such. So this is the value of AC in centimeters. Right. So once we have done this, it means we have really expressed our answer in a simplified SAD form. Right. So that's it about example 1. Right. So let's go and see what is there about example 2. Right. How do we express the solution of which in a simplified SAD form? Right. Now, similarly, as we've done with question 1, we'll not run away from that. It's the same procedure that we also have to be handled in question 2, right? What area is there? You use all the mechanisms of working out the particular problem, but our interest is the end part of which is the solution, and that you call it the word the answer of which. So what I want is you not to leave your answer in any decimal form, but it should always be what? In the that's a side form, like we have had here. Right. So let us look at this example together and see what we're going to get from this one. Right. So this one talks about a rectangle. So here we're told that say the sides of a rectangle are 3y centimeters by 6y centimeters, and the asked us to write down the expression of the diagonal of a rectangle in simplified SAD form. What would be the diagonal of a rectangle in simplified SAD form? Right. So as introduced the first problem here to say that say every time when you like to handle such type of problem, come up with the diagram. So we're going to do the same here and come up with the shape. So this one is talking about the rectangle. So it means what I'll do, I'll bring here a shape of a rectangle, just a sketch of this kind, and have it drawn like this. Right. And when you draw a diagram, things becomes easier because it always gives you a guide of what you should do, like this one here. Right. So I may even call it this one rectangle A, B, C, D. Right. So we always expect that rectangle should have what? Right angles. All angles are right angles. That's what? 90 degrees. Right. So they said the rectangle is 3y centimeters by 6y centimeters. So this tells us the smaller value here is representing the width, and the other one, longer one, is representing the what? The length. Right. So we can at least attach those measurements. Let AB, AD as my width, the same as BC there. So I have this one at 3y centimeters. It means from here up to that is 3y. And the length of which should be 6y. It means from here up to that is 6y. It's just simple. Well, problems are not most of the time difficult because it's more like you are being guided on what to do. Right. So simply as it is there, that is the type of the shape or the figure that we are going to work out. Right. So see here what I have. Right. Right. The sides of the rectangle are 3 by 6y. So here's the 3y by 6y. One is the length, another one is the width, as you can see there. So now since we are talking about the diagonal of the rectangle, a diagonal of rectangle is just that line that cuts the rectangle into two triangles, and it connects the two vertices of which opposite vertices. So you can connect this one and that vertex A and C. That line is known as the diagonal. Splits the rectangle into two triangles. Or else you can connect B and D, no problem. So let's draw this diagonal by choosing A and C as our vertices that can be joined by a line which is just like line AC. So it means here our diagonal is AC. According to the question, what the question saying? The question is targeting the diagonal AC. So it's more like, can you find the value of the diagonal of what? Of a rectangle. In simplified way, side form. That's what is here. Right. So now, as the nature of the figures, you can see it. To find this one, to find this line, AC, which is the diagonal of the triangle, of the rectangle, it's possibly the same what I mentioned earlier, that each time you'd like to wake up the length of something, try to consider the area which have been already done. You have already done in the past. So just wake, it always help us, because there's one concept that we did there about Pythagoras theorem that targets always right angle triangles. So I accommodate that, because when I see my figure here, it is a figure which has got what? Right angle triangles. So I can try that one. If it doesn't work, then I'll possibly see what other areas of concern that can help to find the value of a missing side, possibly if they are going to tick. Like, so let me begin by using the Pythagoras. So my target here is to find AC, but now to find AC with the diagonal, I'll use triangle ADC as part of that one. Right, so here I'll just depict part of this one and draw it something here like this. Like this. Right? So this is A, this is D, this is C, and this is 6Y, this is 3Y. What I want is AC. Right. So by the first, let's have the statement of Pythagoras. I'll write here to say, by Pythagoras theorem. Right. State the statement. This is already my hypotenuse side, the wrongest side. It's opposite right angle. So I always begin by writing that one to say the square on the hypotenuse side is equal to the sum of the squares of the other two sides. The sum means addition of the squares. So I'm squaring this one. I'm adding what? A DC squared. Right. Remember that. AC squared is equal to AD squared plus DC squared. My target is to find the value of AC, which in this case is the hypotenuse. So for the AC, I don't have anything. I'll just write AC squared here. For the AD, I'm going to have what? 3Y. So I have got 3Y here squared plus DC, which in this case is 6Y squared. Like that. Then what do? Just have to simplify that one out. Then here we are. We have got our AC squared, right? Which is 3Y squared. So when you square the 3Y, that one gives you 9Y squared. Plus, there you get the 6Y squared. And when you look at the two, these are like terms. So 9Y squared plus 36Y squared, that one gives us 45Y squared. You go by that one. This part, these are expressions, but still more, the method take the same. Right. So what do you do there now? We need to find the value of AC, which is the diagonal. But now in this case, since we are asked to leave the answer in simplified third form, we'll do like we did in the first example. We are not going directly to find the root of this one by taking the square root of 45 and also it goes, no. But what do we do here? We take the square root on this side here, which is AC, and here we're also just going to take the square root of what? 45Y squared. So now from there, what is it that we have? You'll be able to see that on this part, since they say simplified third form, so it means the same knowledge has to be applied. Though here, this is an expression. That should be able to apply. Find two factors of the term inside. One should be a perfect factor, another one should be a irrational factor. Right, so if you can take your time here to assess this term inside the root, you'll be able to realize that the perfect factor of which you can find the square root, here it is a 4y squared. That can be multiplied by, not necessarily 4, of course 4 is smaller. Here we can go for 9. Let's get a factor 9. In 45 here, there's a 9, which can be multiplied by 5. So here it means you can have talk of a 9y squared. It is 9y squared, which is multiplied by a 5. So 9 times 5 give us 45, and the y squared is that. So the two factors of 45y squared are 9y squared and a 5. This is your irrational factor. This is just a perfect square, a perfect factor. So if you go for this one out and simplify, you have the square root of 9y squared as 3y, but the square root of 5, you can't have it, so you just write this one in the root like that. So here you conclude that, say, your AC is equal to 3y root 5 centimeters. Right, so you can write here something like centimeters on this side here. So you have got a limited space here, but that's an issue there. So our AC here was always going like this one. You don't have to read this one out. C squared like that. So this is the way you can handle this problem here. Right. So my target was the always talk of the simplified third form. So is the target here the moment you have reached at this stage? Remember what to do. Don't proceed in obtaining the root of 45, which will be decimal fraction, but rather just break it in two factors for the whole of that term inside into 9y squared multiplied by 5. Right, then proceed this way. Right. I think by this, at least an issue about the expressing a number in simplified third form. It can be the answer itself or whatever is demanded in the question. The moment they say leave something in simplified third form, this is what it means here. Right. So we have this one into this one. It means this is simplified form of this answer. The answer already here, but this is just like a simplification of this. Right. Thank you very much for that. Now, before I go, still more, let me just give you one problem that maybe you can look at before we finally close the topic as such. Right. Just one, find the length of the hypotenuse of a right angled triangle in simplified third form, whose right, that's whose length of the two sides of the other. Let's talk of the other, not just the two sides, but of the other two sides are 1, 3 root of 13 plus 5 centimeters and 3 root of 13 minus 5 centimeters. Right. So here, find the length of this hypotenuse of a right angled triangle in simplified third form, whose length of the other two sides are this one and this one. Right. By this, we mark the end of our topic. I'm very happy that we have been together. Right. I'll always urge you to revisit these videos following the link that is down here, so that you really master the concept now and again. Right, please, students, revise. We'll be able to meet again in the other lessons to go that will be coming ahead of us. So I also ask you to always stay tuned until at the very end when we're going to finish everything. Thank you very much for that.